Okay, so this is a catch-up screen for the next two combined exercises, just to make sure we've taken a look at all of the commands and features. So let's start at the top. RSVP MTU signaling. Obviously MTU is a big deal. It's going to become a bigger deal as we're running multiple layers of encapsulation, tunneling, multiple shims. We at least want to be able to see what we can get down the RSVP path. So by turning on the MTU signaling, even if we don't turn on the fragmentation, allow the fragmentation prior to the MPLS, it allows us to use the command show RSVP session detail, and that will then show us the MTU that can be sent. Very useful. So for troubleshooting alone, we need that. Subscription, yes, you can oversubscribe the bandwidth on the interface. So that can either be a percentage number or a number out of a large number, which can be seen when you type it. So that's quite good. The term aggregate here on the RSVP interface, obviously this is just the RSVP messages, not to be confused there, nothing to do with set protocol LDP deaggregate. Almost feels silly writing that up, but it's the type of thing that can catch you. The LDP deaggregate obviously is talking about actual MPLS labels, and here we're just combining messages on an interface. Okay, so that could be a gotcha. Right, let's have a look at the next part. So set protocols are SPF traffic engineering for RSVP, but not LDP. Okay, let's just clarify this. So LDP is a protocol in its own right. Its metrics aren't very good, so we want to use the IGP metric, either on ISIS or OSPF. That would be good, saves using effectively hot count. And also we can turn on LDP synchronization, whereby if the LDP isn't synchronized, the OSPF or the ISIS won't advertise the line, or they'll advertise with the high metric. And that's really the extent there of that particular interaction. RSVP uses the traffic engineering database, which are the opaque LSA 10s. So RSVP with OSPF and with ISIS, we want to use the traffic engineering database. And that's on by default with ISIS. Set protocols OSPF traffic engineering turns on the TED database on the OSPF. Okay, so so that's that. What we have in this particular example is we have a label switch path here from R1 to R3. Now, R1 is sort of sitting on its own. It's a single OSPF router. The other routers are running ISIS. So although it's running OSPF, it's not running the TED database and doesn't need to be because it's a single box. So we're actually turning off the constrained shortest path first here. And we do that at both ends because it's not going to make any sense. Okay, right. The next little part I want to point out here I just wanted to refer back to path selection. We had the revert timer. When an LSP goes down, if you set the revert timer to 0, then obviously the backup path will stay up. Now what we've got here is we've got a couple of secondaries. We're actually selecting this one as manual, and what that means is it needs to be up and working for it to work. So it's just a clarification there. If this path is down, don't use it. And I think that picks up those details there, hopefully.